Hello and welcome to this RealFlow 101 tutorial. This tutorial tries to be a quick guide for those of you willing to learn the basics of the software. We will be using a step-by-step approach to guide you through, starting from the download and installation process. We will then introduce you to the RealFlow 2013 interface, so you can familiarize yourself with it and start working on examples for the most important features. The focus will be on High 2, which is one of the main features in RealFlow 2013, but we will also be sharing some general tips and tricks along the way. Let's get started. Downloading the RealFlow demo should be pretty straightforward. Just go to the realflow.com website and find the download area. Once we go there, we introduce our email address and simply hit the download. Apart from downloading the RealFlow package, we may also have to download the RealFlow connectivity plugin for our 3D platform of choice. If we look at the RealFlow pipeline, which we tried to make across all the RealFlow users for the last year or so, what we're trying to do here is to stress the fact that with RealFlow is not just a simple package. We do have the GUI that interacts via the connectivity plugins with your 3D platform, and we also have the RealFlow nodes and RealFlow render kits. If you just downloaded the demo version, you may only be using the RealFlow GUI. But if you are a Learning Edition user or a standard user, you will also have probably RealFlow nodes to send simulations to your render farm or Maxwell previews, and you will also have the render kit plugin installed in your 3D platform to help meshing at render time. Connectivity plugins we do have for most of the 3D platforms that are used in the VFX industry. And we keep this page here in the online documentation, where we have the latest versions of the software that we support in each plugin. So we have 3D Studio Max, Lightwave, Sofimage, Houdini Production Builds, Maya, and Cinema 4D. Thanks to the Alembic integration that we have made inside RealFlow 2013, we also have compatibility with other packages such as Modo. If you want to use the whole pipeline, you may also need to download some other packages that come from the download area, such as the RealFlow Job Manager, which will have to be installed to manage the processes sent to the farm, whether they are simulation or preview renders, and also the Next Limit License Manager, which will be the one hosting the render kit licenses for the Learning Edition users. And for the standard user, they can host all the licenses in the RealFlow pipeline, the RealFlow GUI, the RealFlow nodes, and the RealFlow render kits. Since RealFlow 2013, RealFlow Learning Edition, we go to license type here, and RealFlow Learning Edition includes a RealFlow node and a RealFlow render kit license. So even the learners can work within the environment close to that of a professional studio. But remember, the Learning Edition is not commercial only. In our online documentation, the users can find frequently asked questions on how to install licenses in the License Manager and also the Job Manager. And if you go to our RealFlow Labs channel, there are playlists that can help you set up the Job Manager, some tutorials on how to use nodes as well, and you can also check what's new on this latest 2013 version. And on top of that, we are creating more and more tutorials on RealFlow Graph, which are another powerful feature. But don't forget that we also have, let's go here and we go to the community. We have the official forum, the unofficial forum, some other great resources out there like Luis Miguel Mora's blog, which is one of our colleagues here at Next Limit, that is a great source for tutorials and tips and tricks with regular additions. The first thing that we get when we launch RealFlow 2013 is this splash window telling us that now in the help menu and the demo scenes we have a collection of demo scenes for us to learn. So if we simply click browse, what we have in here you can see that especially in graphs, which are one of the most powerful features that we have included in this version, and also in Hybrido, we have a nice bunch of them. We can also go to the RealFlow resources site and find new ones that we keep uploading, and also the users are going to be uploading. Now, for those of you that might be not familiar with RealFlow, the interface is pretty much as with any 3D package, very straightforward. We do have a perspective view, and we can also have a quad view here showing 3 orthographics and one perspective. We can play around with the layout by simply moving around the windows wherever we want to put them, so we can reorganize and make the setup as we like. We do have a relationship editor here, where this is new in 2013, where we're going to be creating most of the time the nodes that we need for our simulations. We can still create them the old way, which is by accessing the shelf that we have up here. And as you may notice now, we have everything color-coded. So we have Hybrido is white, blue is for particle-based solvers, SPH. These are the forces or demons that help us drive our simulations. Yellow is for RealFlow primitives, geometry primitives, and also for some of the dynamic things that we may be needing, like multi-joints, which is constraints to glue together the pieces. We have green for meshes. We have here the 2 meshing algorithms that we have inside RealFlow for particle-based solutions, and also the hybrid one. We have cameras, RealWave, which are the oceans, surfaces, and IDOCs, which I will get into once we start working with Hybrido mostly. So now that we have here a simple emitter, RealFlow, as we keep saying, is very straightforward to use. So with just that node, we can simply hit simulate, and it's going to ask us to save the scene, so we can put this, and we got something running that doesn't do anything on its own. So what we probably want to do is add some geometry on the scene. We can come here and add a plane, and by default, they are not connected unless you have a hub, which is, I believe, what comes by default here. We can edit, add to default hub. If we have this ticked, then anything that we create after that is going to be linked to the hub. So, for example, if we come here and we create a gravity force, it's going to be connected there. If we wanted to connect everything to the hub and we play the simulation, what we see is that the fluid is colliding with the plane. How do we know that these are connected? We can come here and say show implicit links, and it will show us all the connections in there. This is similar to the previous version that we have in RealFlow, where we had exclusive and global links. This would be the global links. We could get rid of this, and instead of having a global link, simply drag and connect them, and it will be doing exactly the same. The only difference is this way is kind of neater, and if you have multiple nodes in the scene, it's easier to organize them that way. So what's next? We have a fluid solver with some forces attached to it and some geometry to collide. What we want probably in terms of finishing is to add a mesh algorithm, so these particles get a wrapper around them, and we can apply a material and get that to render. So as I was saying earlier, for the particle-based solution, we have 2 meshing algorithms. One is the legacy one, which for some users still valid, but it's not multi-threaded. This is mono-threaded. The one that is multi-threaded and is the one that you will see when you think of the RealFlow pipeline on the RenderKit plugins is the RenderKit particle measure. And in this version, this has an anisotropic measure. Anisotropic is good for thin fluids, when we have a thin layer of fluid where we want the mesh to be close, tighter to the particles. Isotropic, well, it will depend on the type of situation that you want. How do you want the look of your meshes? So if we simply right-click here, we get that mesh build. And now also a new feature inside 2013 is the ability to render with Maxwell Render Fire Engine, which is the fast interactive render engine. So if I simply hit click in this button, we do have a quick render of that mesh. By clicking on the stop button, just stop the render. We can freely move. This is interactive, and we can orbit on the scene for any node inside RealFlow. We can come to the Maxwell tab and apply a material. We have a nice collection of materials here. We could apply honey material, for example, and I will get change straight away. We see the particles inside here, inside the mesh. This is because we haven't hide them. So if we can do the particles, we can either hide them or we can set them to be hidden from Maxwell render. So I can do that, and it will. You see that this voxelizing. That's because the scene setup is being changing. I mean, if we don't change anything on the scene, we can move around freely, and it will be just simply updating interactively. We can change the material, no problem. We can go to the plane, and we can either apply a Maxwell material here, or we can come to the node and default setting and just apply a single color, for example, and that will get changed interactively. Maybe we want to apply a water material to that mesh. We do have two types of water here. So that's the easiest way you will find to render something like water. Maxwell doesn't need a Maxwell render license, it's just for pre-visualization. So if you have RealFlow nodes in your render farm, and this is one of the big advantages, if not the most, of having Maxwell integrated in RealFlow, is that you can send your previews to the farm. If I come here to the Maxwell parameters, we see that there are not that many. It's pretty straightforward to use. You just play with intensity, whether you want to use the physical sky or add your own geometry with light materials. You see here we have a material that is coming from a file with installation. So you can create your own Maxwell materials inside your 3D platform and link them through here. You set the image quality, the number of threads that the render is going to be using. Global scale is related to the light transmission on certain materials. It's going to be different whether you have the right scale or you're playing with the multiplier on the scale in the scene scale, or your geometry comes at a different scale from your 3D platform. And these settings here are for the preview once you send that preview to simulate in the farm. For example, the motion blur is not going to be showing in Fire, but it will show in your final preview. You just set the maximum amount of time that you want the render per frame to be, the maximum sampling level, which is the grain that you want to have in the preview, pretty much. So you want less grain, just increase the sampling level. And now we have the draft or the production, which is a full Maxwell render. So you have a full Maxwell render for free, and this one will be calculating caustics faster than the draft. They converge, but if you use the production one, you're going to be seeing the caustics sooner in the preview. Just apply, and now we can have that preview sent to the farm in two different ways as well. You can come here, and we have the send to preview to job manager, or we can come here and send it to the command line. So we can either calculate that Maxwell preview locally, or we can send it to the farm. This is still running, that's why it's showing this here, so I can stop it. Okay, so let's close it. Something also worth mentioning is that in any parameter, you always have the option to click on the parameter and press F1. And this will give you a link to the contextual help that comes from the manual. If you don't find what you're looking for, or it's not enough, the info that comes in there, you can always click here. That will take you to the manual that is within the installation. This might not be the latest manual, since we keep reviewing it and adding stuff. So at the bottom of each page, you will get the open latest version in online documentation, and that will be linking to the online manual that we have in our online resources, support.nextlimit.com. In this video tutorial, we're going to try and show you quickly the basics of the new Hybrid 2 solver that we have put in place in RealFlow 2013. basically what we have done is to speed it up massively by replacing the base solver. Now it's a flip solver, so we can, if we look here in the simulation options, run as low as 1 substep per frame. We can also make use of some GPU acceleration by simply clicking here in the system information and checking our devices to make sure that they run on OpenCL 1.1. We will make sure that we can use them for higher speedup. To be honest, it doesn't give you a huge boost. We like to say it's pretty much 1 extra core, so I wouldn't use it in this demo. And the other thing that we have put in place for Hybrido and also for other simulations at RealFlow is the ability to send to command line, which is very helpful because it allows you to keep working on a different scene or even the same scene while simulating in the background. I'm not going to be using that one either right now. So I guess you all know by now that here lies the whole Hybrido system. And I like to stress before I start with anything that one of the most important things about Hybrido is to plan ahead and know your workflow. Hybrido, the name itself implies 2 solvers working together. One is a grid-based solver, in this case a flip solver, and the other one is a particle-based solver that we have also revamped by creating HiSPH, which is a version of the SPH that we had since day one in RealFlow, but way faster, more memory efficient. So, if we go to the Hybrido menu and we create a domain, the first thing that we notice compared to the previous versions is that instead of getting a queue like we used to have, which kind of resemble the boundaries of the domain, what we get is a simple gizmo that still shows us the resolution at which we are going to be simulating. These cubes here in the corner tell us about the cell size that we're going to be using for the simulation. And as you know, RealFlow grid units are 1 square meter. So this, by default, if you go to the top view, for example, this is approximately a third. And if we come here and check the cell size, it's 0.3. So it's a third of the unit, which is by default. I'm not going to go all over the parameters that we have here, but I might be able to comment on some of them. For a specific simulation might be handy, like, for example, in here, and this is very important, and if you have a lot of memory in your computer, like I have 24 gigs in this one, I can use a dense mode instead of an adaptive, which is the default one. Adaptive means that since we don't have this cube grid anymore, the fluid is going to be flowing everywhere now instead of hitting the walls of the domain. And it's going to be using memory only in the parts where the fluid moves through. So it is much more memory efficient. But if you have enough memory in your system, using the dense mode is preferred because it will go twice as fast normally. So for pretty much any simulation, if you have a lot of RAM, use the dense mode. Then if we come here inside the fluid dynamics, one that is kind of handy as well is if you're working with flat surfaces, like you have, for example, a boat that is cruising a sea and you don't want to see much interaction from the particles that fly to the air and get back to the main body of water. When you mesh, then you can get rid of those by using these track-only particles. Normally, you don't want to do it as well because it takes time, and once you mesh it and you add extra detail on top, you might not need that. And then also you have the ability to export vorticity and normal channels to your simulation. Don't do it if you don't need them. As with anything, this takes time when you start adding things on top. Then we have renamed the displacement capabilities from Hybrido. Now they call Ocean Statistical Spectrum to match the same naming convention that we have in the real wave statistical spectrum and also in the simulation graph nodes, but this is pretty much the same that we had in the previous version. So just keep it simple. We have a high domain node, and if we hit simulate and just simply save, Hybrido, nothing happens, and that's because we don't have any volume to emit from. So let's create let's do a down break. If we have something like this, perhaps Let's try to make some proper units. Say we create 25 by 10 by 10 units. And we move it 5 units in Y, so we are at ground level. This will be like our boundary for the simulation. So we need this cube to collide with the domain. We could either leave it as is and use the hub, which is a global connection. So if we come here and show the exclusive link, we know that the domain is going to be colliding with that cube. Or we can, and I rather do that, get rid of the hub, take it out of the equation. So we come here and say, I don't want the default hub. So anything that I create from now on won't be connected to a hub. But I want to make the connections, maybe organize this that way. What else do we need? We need an emitter, so we can simply duplicate that cube and scale it down. So it kind of, let me just position it properly. And we move it back and we say, okay, we're gonna rename it. It's gonna be cold water emitter. And this one, we're gonna rename it to walls. So this doesn't need to be linked there. What it needs is to be linked to an emitter. So the emitter, as I had selected the water emitter node before, gets properly linked here. And this is the one that we need to link to. So now we have an emitter. We could choose whether we want this to be on a stream mode or simply a dump break. Maybe easier to have it on stream mode. If we do a stream, then we need to check the direction of the emission. Maybe we want to put it like that. Perhaps we can even angle it a bit so it comes, it's gonna come through this corner somewhere, somehow. What we need to add now is also an initial speed. So let's say we emit at 3 meters per second. So let's save this out and simply hit simulate. And what's happening now is that since we have linked the walls to the domain, and this is very important also in this new version, we have to come to the volume tab for the geometry and tell the solver which type of volume are we using. Since we're using a solid inside by default, it's not going to be emitting any particles inside that volume. What we want is solid outside. If your geometry is not closed, then you will be using the shell mode. And I believe we do have a new primitive here we're not going to be using now, just a cube tube open. That is a good example of shell. If we create a one, by default, it will be shell. So let's get this reset, hit simulate, and we now see that we have the stream emission as expected. So let's go back. What else do we want to add in this down break sample? We can add also a gravity demo. Most of the demos that we have here work with hybrid. Not all of them, and we will try to improve that and make them work, but right now pretty much most of the important ones are working. Let's hit the G key and get rid of the grid as well. So we link the gravity to the domain, and perhaps, and this is something that we want to, when we do in R&D, we want to reduce the number of particles to create faster turnarounds. We can come either to the scale options here and modify the cell size scale. The cell size can at two different levels. One is at the domain level, which we have seen already. The other one is at objects level. So every object has a cell size. And these two has to match pretty much one-to-one if we want proper collisions, etc. Sometimes we may need, or we may not need, the objects to be rasterized that accurately, so we can get away, depending on the distance from the camera, etc., with not that perfect collisions, and so on. So we have two options. We can either link this or select and start changing these values here, or we can come and do a quick global scale. For example, I want this to be twice as big. So So we see that this has changed, and now instead of simulating at 0.3, we simulate at 0.6. And this will make our test run way, way faster. So now we have our dam brake. What else can we put to demonstrate the workflow? We can put some collisions here, for example. Let's use like a cross body. Fine. Let's place this cross, or maybe not a cross. Let's put a cylinder so we can create a dummy lighthouse, for example. We can put that there and say, all right, a lighthouse, angle 8. And what we need to do is to link the cylinder to the domain. So once we have that working, we will see that the fluid is going to be colliding with our dummy lighthouse, and what we're going to see instantly is that the level of detail that we get with this flip solver compared to the old solver is way, way better. Now, another trick to create more particles without reducing the cell size is incrementing the number of particles in the emitter, in the surface, and in the core of the fluid. And why is this better than, well, it's not better, it's just more effective because, as I said, it can allow you to do faster turnarounds and tests than if you start decreasing the cell size, which takes way longer and also takes much more memory. So let's hit reset here and save the scene. So as I said, a good way of adding particles, and if we come to the help menu, we can check in the hybrid fluids in the emitter section what this particle sampling does. The number of particles is the surface particle sampling at the power of 3, so number of 2 means that we're going to have 8 particles in the surface. So instead of 8, we want to place a bit more. Let's say 3 and 2. That will give us quite a nice detail in the surface. And the threshold between the surface and the core is defined by the bandwidth here. In this case, it's just 0.1. So depending on the number of particles that you want to place in each area, you might want to modify this one. 3 and 2 is the okay value for now. So if we hit simulate, maybe if we stop it and we go to an orthographic view, go back, you see that we're getting more particles. Perhaps it's not the best to show it with the stream. So we just make a down brake to show this bit and crank it up a bit here. And we see that we get to see slightly more particles when we start increasing, because we have a very low cell size. Due to this, maybe we're not getting to see the effect that much. This is 3 now. Go back. There you go. So here we see that we have a thick area in the surface and then less particles in the core. See if we can run like this in the demo. I don't want to be simulating and stopping and playing forward. So let's run this simulation maybe so we can get the particles cached, and then we can move to the secondary elements, which is the other part of hybrid that you know is needed 99% of the time. So it's a few more frames. Okay, I think we can leave it at like around 40 frames, and then we will generate secondary elements. And Okay, let's take this down to 40. Well, 40. There you go. So what's the next step? We do have this nice splash, and what we want to show is something coming out of this edge in the form of splash. So the easiest way is simply come here, set the fluid domain to be cached, and now we can also show you what we have done in the export center section. From here, you know that you can export. In previous version, we did have the GDC fluid domain caches. Now we have two different formats to define that same thing. One is a RPC, which is a RealFlow particle cache, and which allows you to export just what you want if you don't need to be counting on multiple magnitudes. You can skip them, so your files will be a bit lighter. Think that once you start working with massive scale scenes, the file sizes are going to get really, really big, and you need to be careful with your hard drive, especially if you plan to do some iterations. The other important file here is the fields cache, and the fields cache is needed if you plan to do secondary elements, so you cannot skip these ones. These are the default ones. Now, what are Field3D and Alembic formats here for? If your pipeline is built on this open source format, you can choose them instead of the other ones. So you could generate the secondary elements as long as you have a field cache, whether it is GFC or Field3D. The downside of Field3D and Alembic is that they are not native to RealFlow, so they have to be taken through a conversion process that will increase your memory at times. So it's up to you whether you want to use them or not. Of course, we still keep the proxy files that can become handy. We have improved the Krakatoa formats too. But remember that you need the the fields cache if you plan to do secondary elements. So now that we have this and we wanted to create splashes, we just simply come here and say, okay, maybe we want to create a splash form. And we get the box. Remember that they bound it, and we place that box surrounding the dummy lighthouse that we have created here. And we simply come here and link the splash to the domain. If things get complicated, you can always come here to the spreadsheet and right-clicking, you can disconnect multiple nodes at once. So, what else does the splash need? It needs probably a gravity, and it is handy to add collisions with the cylinder. Perhaps we can move these things around so they show the interaction clearer. And we may want, and this is very useful normally, is to add a kill volume. So the particles don't fly all over the place but get killed when they leave certain areas. Quick one, how do we scale this at once without having to using the manipulator? We simply use this cube, for example, shift, hit click, come here, and now if we click the kill volume is set to the size of that cube. So we may not need or want the splash particles to die at the edges, but a bit farther away, so we just scale them up a bit. Same on height. So let's say this again and do a quick run. Perhaps we want to hide the domain, so we get to see the splashes, and there you go. These are the splashes being generated pretty fast. This is another thing. We do have the highest pH solver in place here, and you have seen how fast they simulate. Okay, they are not that many particles, but they are still over 100,000 particles. And I could come here to the splash and crank up the rate of emission, and it will still be pretty fast compared to the previous version. So we get into a decent number in not much time. Good thing is now we have also Maxwell render and Maxwell likes particles. Ooh, and cubes too. So let's hide these walls to Maxwell. And we can see those particles there as a simple point cloud. So let's stop this Maxwell. Yeah, not done. Not that yet. So we have a nice splash cloud here. If we show the domain, we see that it fits with the domain, but not as nice as it could be. For starters, it's not liquid. By default, splash and foam particles are damp particles. We can use them as liquid, and that will take slightly longer. Now, how much longer? Well, it will depend on how much or how many substeps we have decided to put in here in the max substeps. These are the substepping options for a hybrid solver for both the flip solver, which is in this area, it's around it, you cannot miss it, and the high SPH. By default, and for a lot of simulations, you will be more than happy running them at 20 as a maximum. Perhaps we want to have 50, which isn't that big. One thing to bear in mind is that these numbers here have also to obey this one. If we put a lower value here, and this one normally, most of the time, will be just for SPH, then we have to increment this here. So let's hit simulate, and now we're running, remember we're running liquid particles, so it might take slightly longer to simulate. You see, it kind of slows down a bit, but the amount of detail that you're going to get with the liquid particle solver is, in my opinion, much better than with the damp one. You can still move around while it's simulating, which is also a good one. You can do a few things like hiding, and you still start to see that you get the surface tension working there, so you might get nice tendrils of water, like these ones here, areas that show the proper liquid effect that we were missing with the damp particles. If I simply stop here, one other thing to show is for both high SPH and high readout, we do have now in the display tab the option to show the rate of particles. So we can come here and say 50%, it will run faster in the viewport. It wasn't that slow, it was pretty fast actually, but if we were working with 100 millions of particles, it would be a good thing to have. And we can always also fine-tune the shading of the particles, so we get to see something better. Like that splash is pure white now, maybe we want something not yellow, but we may want something that looks closer to what we have in the base, so we can see or do our OpenGL previews in a nicer way. I don't know, just a thought. So what's missing here? If you see this in cache mode, you see that we only have splashes around that area, but we probably want more splashes all over the place, like on the lip of that wave of the edge. Well, that's where the IDOC paradigm comes in place. Instead of running splashes like that, what we probably want to do is to send multiple splashes to be simulated at our RealFlow nodes in the farm using the job manager. And a quick way of showing you how that could be done is, for example, if I delete this splash and foam and I simply hit the area that we are using to simulate, I can create a multiple IDOC there. And I could say, okay, I want, let's say, 3 IDOCs in the Z axis, or maybe 5. 5. So it has generated 5 IDs, and I can come to the hybrid tab and say I want a splash per iDoc there. So it is currently generating splash per iDoc. And now this becomes a bit of a mess. So that's one of the reasons why I strongly recommend to start creating things like notes, moving things there and telling whatever it is that you put in each area, etc. So basically trying to work with a bit of planning and not with crazy setups. So instead of running this scene any longer, which is going to be a bit convoluted, I could simply come here to the demo scenes, which we have put in place among other reasons for you to learn the basics. And we do have a iReal Basics IDOCs. If I open the one, we do get a nice explanation of all the secondary elements that we can create. It's a similar example to that one I was showing you before. And this one probably could maximize this window. Shows how do I, again, place all the notes and information around the iDocs and set up the steps that iReal needs in order to work the proper workflow. So basically, you will be generating the base of the domain, the flip solver. Once you have that, you can start sending things in parallel to your nodes in the farm, and all the explanation is there. So just go and check this demo scene. And if you have any questions, just hit us on the forums or in the support team.